Hello everyone, this is Anil and you are watching the YouTube channel Neil Classes. So I welcome you all in my YouTube channel. If you are new on this channel, then I request you to subscribe the channel, like the video, give your comment, and if possible then share this video with your friends. So now we are studying Lagrangian Dynamics, and in last class we have seen the generalized coordinates. So if you haven't seen that our previous videos, then the link of those videos are in description. You can go through that. And today we will continue from there. So in today we'll take some general means formula or general function, like I'll take one function of phi alpha, and this is the containing like x, y, z, or x1, x2, x3 like this, x1, x2, x3 like this, and I am taking here there n number of particles are there in the system, then their total number will be there 3n coordinate and time t. This is the general function. Here I did not remove that constant. I am taking general formula here, including means that coordinates of independent coordinates are also there. So in this one, this is the thing. But if you did not get what is that, this is like last class also I told. If we take a simple pendulum formula, then we can write it like this. X square plus y square is equal to L square. And x square plus y square minus L square, if I take L square is equal to 0, then I can write it. If I want to learn in function at phi, then I can write x, y and L is equal to 0. This is function. So similarly like this, I can write it here equal to 0. Now we will see that this is the function. If I take it means that displacement for that, then so therefore that if I take function of alpha displacement, smaller displacement, and let me take it, this is the means function of phi. Phi in the sense here x1, x2 is the things we will change, or I will keep it directly to the right side. So first I will take alpha. So phi alpha is equal to, we will derive with partial derivative, it's equal to qx1 plus, or this one also comes. So this one means dx1. Now partial derivative of alpha with respect to x2, and or if I take this one means that here for x2 here will come x2 like that, and at last we will get d phi alpha x2 and x3n and dx3n, and at last we will get that will be plus phi alpha del 3n x3n wait not x3n, here we are taking to time with respect to time, so dt. Now if I take a virtual displacement, then what will I do? I will take is equal to, will get, I can convert, wait one step, I will write it again. So phi alpha, this will be same, and it will be get changed to x1. Similarly phi alpha I take x2, this will be get converted and like this, and phi alpha x3n plus del t. Now similarly, which I have shown in this one, we are taking time constant here, so this will come 0. So it will get removed, so we will get this much expression. This one. Now phi alpha is equal to, we will get phi 8. If I take this x1, x2 in the ith term, and I is varying 1 to 3n, and which I will keep like this, phi alpha divided by del xi, and this is del xi. I can write in this way. Which part? The same thing we did while going about the generalized coordinate. Why I am writing, now we will understand. So this one and this function is, what is that equal to? This function is equal to 0. So here I can put equal to 0. Here I can put it equal to 0. And here also I can put it equal to 0. So this is equal to 0. Now I can do one thing. That thing you will understand that later. But if I multiply with any constant with this equation, will it get effect? Like if I am writing means alpha here, not alpha, lambda. This side also lambda. On. So this is equal to 0. So by multiplying here also lambda into 0. So it will give 0. Right? So not right. So from 0. This is the equation number 1. Now at starting equal only V2, which means the Alembert principle, and according that we drawn made force that applied to current constraint or applied force minus P vector dot equal to, we can write, we took here Ri equal to 0 we took. Now this is equal to 0. So I am going to change this change in this equation. So now you will not get why I am doing these things, but later I will tell you that why we did all these things. So I am making some smaller change in this equation. I am taking P dot and adding 0 in this one. Why I am adding these things I can tell, because here is equal to 0. So this one I added. And same thing can I write? Not fact. Okay. So this equation, now what can I do? Then I can write this equation equal to applied force minus P dot and plus, in the place of 0 can I write this one? Can I write? So I can write it like in this form. See, it will be lambda sigma 1 to 3n and 3n del phi alpha divided by del xi xi. Wait, smaller mistake. Means I will note it here. I will add 0 here. I can do. So what will happen? Then after adding here, things will change like this. This is del Ri, or if you want to convert, because this thing I will take in common because both are the same. So here also I will take Ri or like this. So change this means like here. Alright. If you don't want to change this one, you can change it. Means Ri to carry through means this is the general parameter for this function. So we can change because we only consider all these things. So both are same. Here Ri, R1, R2, R3n, R3n, R and R1, R1, like this. If anything left out, here also Ri. So this is the Ri and plus G in the place of 0 here, space of 0, I can write this one. So it will be I equal to 1 3n minus 5 alpha divided by and dot del I and is equal to 0. You can do. Now I will remove. If you want to note down, I did not write this, means I left out this space, but anyway. So now we will remove this part and we will continue with that. So that is our equation. So if let me write it again here. So equation we got like this one, P dot and if I take common here, then so it will be plus lambda sigma I is equal to 1 to 3n, and this is it phi alpha. This one equal to 0. So why did I do this? After means doing all these things, you will get answers. But why did I do all these things? Why did I multiply first of all, why did means what is the need I got that why I had to do like that, and I multiplied with lambda here. So why did I do? So thing is that in this one coordinate, this in function, there if n particle was there, and n particle of system we take, then we need 3n coordinate or 3n parameter. In vision, we don't have any problem with 3n coordinate, but think are that there are in 3n, if any particle system is moving any under constraint, then there was k number of constraints. But what is k number of? These are not independent parameters, these are dependent. So all are dependent. So dependent, our purpose is main purpose was to remove this dependent coordinate. So we want to convert it means in independent coordinate. And what was the benefit of independent coordinate? If I take means consider it is c and if x, then thing is that if all are independent coordinate, then c1, ci let me take, and I is taking or let me take j. So j is taking to 1, 2 means some numbers. So c1, c2, c3 all is equal to depend independent, so we can write in is equal to 0. But if there in that function, if in that function there are some independent coordinates with the independent coordinate, we are not sure if I expand this equation or this one. So there are means if 3 a number of there, then like let me write it. C1 x1, C2 x2, C3 x3, C4 x4, and C3n x3n, like that. So we know all is equal to will be 0. Always if their system is moving under constraint, whatever. But thing is that if we know that independent coordinate, then I can write C1 will be 0, C2 will be 0. If means till C1, C2, C3, 4 means x1, x2, x3, x4 all are independent coordinate, then it will C1, C2, C3, C4 equal to 0. But in this given equation, we don't know which one is dependent or which one is independent coordinate, so we can't do. So these are the difficulty for us. So to overcome from that, what did we do? We did a log means made a function, and with this one we multiplied lambda. So that lambda is undetermined value. I took randomly any A, B, C, D means 100, 10, 200, whatever, any undetermined value, so that value can vanish, or by using that value means number multiplicator, we can vanish that all dependent parameter. Understood? Means like there are 3 n number of coordinates are there. Among 3 n minus k coordinates are independent and k are dependent coordinates. Our main purpose is to remove that k number of parameters, so we can get 3 n minus k. These all are independent parameters. Independent parameter. So using this one, our works become easy. So for that we use alpha. So by using this term, the L means k that number of parameters which are dependent, which automatically get vanished, and we will get new function which will be having like c1, x1, c2, x2. Let me write k1 b, k1 y1, because if you will get confused that time we were taking c1, c1, x1, c2, x2 till x3, and then I change auto. Why did I change? So let me take another. Means both are different. Let us consider. So k2 y2, k3 y3, and we will get till kn yn. And here n is what? 3n minus k, means k terms which are dependent automatically get vanished. So using this method, what did we do? We simple equation there, from there we automatically remove that dependent coordinate. Similarly, if you think that means mathematics also in coordinates, generalized coordinates, we rotated the axis or coordinate axis. We translation of axis coordinate. Why does we do? In like if you have study a function is like ax square plus by square plus sorry plus 2bxy plus cy square plus dx plus ey plus f is equal to 0. So what does we do? We rotate a function such a angle that such angle also there also we are doing such angle which is suitable, and this term will get vanished or this term we can remove. So after rotating this we will get plus cy square plus dx plus ey is equal to 0. Similarly, we do translation tram translation for that coordinate, and we remove this x and y coordinate and we get f is equal to 0. So thing is that by rotating and translating we had equation this much lengthy, and by rotating this our work became easy because the xy terms got automatically vanished. Similarly, by doing translation x and y coordinate system is got vanished, so we got simple equation this one, so we can solve it easily. Like same thing we are doing in this one. So now I hope you understood this. Why did I do all these things? So these things, and here lambda is known as Lagrangian multiplier or Lagrangian multiplier. So using that lambda we can remove all the k number of coordinates or parameter. So these are the things, and this equation are known as a Lagrangian equation of first kind. Equation of first kind. Now this equation we got. So using this one our work became easy because at starting we have had that equation, and the thing was that we had to remove that means dependent coordinate. So using this one method, according to Lagrangian, that he found such a method using D'Alembert principle. This was the D'Alembert. This is the D'Alembert principle, which is like applied minus p dot, and he used this function to, by changing small changing in that we can means become equation will become easy for us. So using that, and what did he do? Lagrange at that time mathematics. He solved this equation, and after solving this, he sent it to Euler. Euler was that time of means famous mathematician, and after showing this, he wrote a letter and sent this means the method that we can do all these things using this method. So after he took serious, and Euler and Lagrange both worked on it, and they got a new idea of the new equation which is known as Euler-Lagrangian equation. So that is the next part of this video. So in the next video we will see that how did we convert it, what are the logic they uses, and why did that need we came that we had to that equation, Lagrangian equation, Lagrangian dynamics, Euler-Lagrangian equation. So we will see in next video. So if you haven't seen our previous video, then I request you to see previous video because we have derived each derivation, each concept with detail. So it will be helpful for you in deep understanding. So link is in description. You can go through that video. So thank you. Bye bye. See you in next video. Ta-da.